Okay, talking about flows now. This is getting into chapter 10. Chapter 10 is actually very short. It's just this one thing. So we'll start with some definitions. A network, this is a network. It's a weighted directed graph. So there are arrows saying you go from here to there, and each edge has got a number, that's its weight. And there's two distinguished vertices. One is called the source, A, and one is called the sink, Z. The weights are called capacities, capacity of 6, capacity of 4, capacity of 6. And then a flow through a network is an assignment of numbers to the edges with the following conditions. Every number is less than or equal to the corresponding capacity. So I could give you a flow of 5 through here, but not a flow of 7, because 7 is bigger than 6, and you can't fit 7 if you only have a capacity of 6. And the flow into a vertex equals flow out of the vertex. So whatever flow goes into here, the flow coming out of that vertex into these two has to be the same as the flow in. If you've done any electrical engineering, you might have seen these as Kirchhoff's laws for circuit flow. I always think about them in terms of water. These are all capacities, right? This can have 6 gallons per minute flowing through it. This 4 gallons per minute, this 6 gallons per minute. I've got an input here and an output here, and I want to be able to know how much water can I fit through this system without it backing up, right? What is the maximum flow through the network? But you can think about it in terms of flows of, well, if you want, you can think about this in terms of flows of spread of a virus through a community. Each vertex is a person, and each weight is how much time you spend with them, et cetera, et cetera. So first off, let's just see what a flow is. So a flow is just saying, I'm starting here and I want to put in some, I'm thinking of this in terms of water, but I put in some water here. Suppose I open the tap and it flows out at 2 gallons per minute. Then I can have 2 gallons flowing through here, and that 2 gallons flows through here, and that 2 gallons flows through there. That's a flow. It's not a maximum flow. You can fit more water through that, but it's a flow, right? I could add another 4 gallons and have it go through there, have 2 of the 4 gallons go through here, those 2 gallons go through here, and 2 gallons through there. Water here splits, 2 of it goes this way, 2 of it goes this way, so I have 2 flow coming in here. Now I have 4 coming in there, so I must have 4 coming out. So I have 4 there, so 6 coming in, 6 going out. So is that still my maximum flow? Well, we don't know. You could probably fit in more. So how do you go about finding the maximum flow? So here's how we can find the maximum flow. One is you just start filling in some flows, right? So from above, we've got 2, 2, 4, and then we had 4, 2, 2, 2, and 2. So there's my flow of 6 going through there. Note that this pipe is at max capacity. You can't fit any more water through there. If we're going to fit any more water through here, it's got to go through this area. So I could fit 2 more, right? Fill this up to 6, send that extra 2 through here at 4, and an extra through there at 6. So now I've got 8 coming in, I've got 8 going out, so it balances. This pipe is full, this pipe is full, this pipe is full. But there's still another pass through there that I can add a little bit more water to. This pipe isn't used at all, but I can only fit in 2 more units before I fill up this pipe. So if I make this 4, it's adding 2 extra units. I can put 2 through there. Then I can put 2 through here. Oops, 2 more through here. That makes that 4. And then 2 more through there. That makes that 4. 10 in, 10 out. Can I fill in any more? Well, this is full. That's full. So what we can look at here is if you look at this, that's a cut. What a cut does is it separates your sink from your source. All the water that flows in here has to go through these 2 pipes, right? That's what the cut does. It identifies pipes that all the flow has to go through at some point. So all of our flow has to go through these 2 pipes. Both those pipes are at capacity. We cannot get any more through there. So what's my maximum flow? It's 10. You can't add any more water to it because these two pipes are already at capacity. Any more water that you add over here will have to go through these two pipes to get to there. And so we're stuck. That's the bottleneck. So maximum flow through there is 10. So that's a general theory about thinking about these things, right? What are some cuts through this network? Like we said, this is a cut that's at 10. This is a different cut. That's got a capacity of 12. We can put 12 units in through here, but as the water flows through here, we'll get a backup at these two because we've got two more coming in than this cut can handle. We can also do some kind of weird looking cuts. We could do one that goes like this. This cut is 12. Right? So that cut separates our network into these three vertices. That's on the source side. And these vertices, these are all on the sink side. When you're thinking about the capacity to cut, you have to be a little bit careful. You only want to count edges that are going from the sink side to the source side. So this is a flow this way. This is a flow from sink side to source side to sink side. This is a flow from source side to sink side. This flow, however, is going back from the sink side back to the source side, right? It's flowing backwards across the cut. Whatever water that goes through here came from over here, and it has to leave through over there, so we don't actually count this because it's just would be counted in that area and in this area. So whatever water is flowing against the cut, right, flowing backwards, you don't have to count that in the capacity because that water is already counted for here and here. So the capacity of this cut is 6. Don't need to count that one. Plus 4 equals 14. Okay. So how do you find a maximal flow? Instead of trying to fill in flows, try to find the minimum cut. Find the cut that has the lowest capacities. It's a bottleneck. The entire flow has to go through the cut, so the flow can't be greater than the flow through the minimum cut. So for example, here's a complicated looking thing, right? One cut is here, 15, 19. One cut is here. This one is also 19. So we know there's a maximum of 19 units can go through there, right? The cut at the source, the cut at the sink, those are sort of obvious limitations in your flow. Can you actually get to 19 and flowing through here? Well, you can look at various places. You could do a cut right through here, for example, not through the vertex. Cuts can't go through a vertex, but through there. And this cut has a capacity of what? 5 plus 3, that's 8, 10, 14. That's got a capacity of 20. So that's not our minimum cut. You could do a cut, say, there's a bunch of 2s here. That looks like those could be short. So if we did, say, this cut, right? What's its capacity? 3 plus 2 is 5, plus 2 is 7, plus 3 is 10, plus 4. There's a cut that's 14, right? 5, 8, if I got my math right. 5, 8, 10, 12, 15, oops, 19. I almost forgot the 5 up there. So that cut is 19. Same as my input and output. What about this cut? Right, and that's in red because that's going to be the minimum cut. So 7, this is going backwards, right? So we don't count that. Plus 4, that cut is 15, right? So all the water on this side, to get from this side to this side from the source of the sink, you have to go through this pipe or that pipe or that pipe. And you can only fit 15 units through there. So the maximum flow could be 15. What is the maximum flow? There could be a lot of different maximum flows. You could take 7 units through here, and then you have to sort of figure out where that 7 units go through. We could put 7 here. Going backwards, we could put 5 through there, and then this vertex has 7 coming out, so I have to have 2 more coming in, so that's 2 that way. This vertex can only, well, we can take all 5. Well, let's go through the top. We can take 3 of it, this 5, 3 from here and 2 from there, and then all 3 from there, 2 from there, and 2 from there. 3, 5, 7, so that's that 7 broken up. And then you have to take this 4, trace it back through there. Where can you do that? And see what you can do with that. So you can find the maximum flow. There'll be a bunch of different possible maximum flows because it's a complicated network. Find the minimum cut, right? What's the cut that gives you the least amount of flow?